Hello and welcome to Maths with Mr Amison. In this video we'll be practicing converting fractions to recurring decimals. If you need to recap this topic then please watch Mr Chowdhury's video or watch my video if you need to recap how to convert between fractions, decimals and percentages. To convert 1/6 to a decimal then, that's what I'm going to do. I'm going to start by converting 1/6 to a decimal, talk through it afterwards and then give you time to copy it down and have a go yourself. So here we see that in order to do 1/6 as a decimal, we need to recognize that this is the same as 1 divided by 6. So if I do that division using the bus stop method, 1 divided by 6, 1 inside the bus stop, 6 on the outside. 6 doesn't go into 1 at all. 6 is too big, so it goes in 0 times. But 6 times 0 is 0, but we needed 1, so we have a remainder of 1. So I can continue to put placeholders of 0 after the 1. So this first decimal place has a placeholder of 0, and the remainder goes next to it, because the remainder was in the ones, and the placeholder was in the tenths. So we have 10 tenths now altogether, which is what 1 represents. 6 goes into 10 one time. 6 times 1 is 6. So we have a remainder of 4, because 6 plus 4 gets us to 10. So we have 1 above, and we have the remainder of 4. 6 goes into 40 6 times, because 6 times 6 is 36. And then we have a remainder of 4 again. So we continue, and you could see that we're always from then on going to get 6 going into 40 every single time. So we'll always have 6 remainder 4. So we have 0.1666, and it carries on. So 0.16 recurring. Now the dot for recurring always goes above the digit that is repeated. If we have 2 digits repeating, then we have a dot over both of those digits. If we have 3 or more digits repeating, then the dot goes above the first and last digit that is repeating. Okay, so take time to write this down and then have a go yourself. Pause now. Now you've had a chance to have a go, let's go through the next question. 5/6, that's the same as 5 divided by 6. 6 goes into 5 0 times. We have a remainder of 5, sorry. 6 times 0 is 0, we need 5 more. So we can put a 0 placeholder in, and the remainder 5 goes next to it. We carry that remainder. 6 goes into 50 8 times, because 6 8s are 48, which means we have a remainder of 2 to put next to our placeholder of 0. 6 goes into 20 3 times, because 6 times 3 is 18, which means next to our 0 here, 18, we need 2 more to get 20, so we have a remainder of 2. So you can see again we have 6 going into 20, which goes in 3 times with a remainder of 2, and it would carry on and on. So you can see that we have 0.83333, so 0.83 recurring with the dot above the 3 as our answer. So 5/6 is 0.83 recurring. Here are 6 questions then for you to try. They do link together. You may be able to use previous answers to help you to get part B, or previous questions to help you answer the question you're on. But use the method I've been showing you. Use the bus stop method to help you to answer these questions. So the answers to these are now on screen. 2/3, 0.6 recurring. 2/6, 0.3 recurring. Recognise that 2/6 is the same as 1/3, so that makes sense. 2/9 ends up being 0.2 recurring. We have the 2 repeating, and 7/9 ends up being 0.7 recurring. So whenever we have ninths, the number that we have as a numerator ends up being a recurring digit. So 1/9 would be 0.1 recurring, 2/9 0.2 recurring, 3/9 0.3 recurring. 9/9 would be 0.9 recurring. But then that suggests also that 0.9 recurring is the same as 1, which in fact is an interesting point there. 7/6, well, just to show that we can do this for fractions that are improper, we have 1.16 recurring, so 1/6 was 0.16 recurring, 7/6 is 1.16 recurring, 8/6 ends up being 1.13. It's 1 and 2/6. With 2/6 we already got as 0.3 recurring. 8/11 ends up being 0.72 recurring, where the 7 and 2 repeats over and over again. It goes 0.72, 72, 72, and so on. 7/11 that is, we get 0.63 recurring, where the 6 and 3 repeat in that pattern. 6-3, 6-3, 6-3. Notice that those there, 7-2 and 6-3, are the numerator of the 11ths multiplied by 9. That's not a coincidence. That is, in fact, what happens every time. 7 times 9 is 63, 8 times 9 is 72. If we had 5/11ths, it would be 0.45 recurring, where the 4 and the 5 both repeat. 7/12ths. 12ths are interesting because here we have 2 digits repeating, but we also have a digit that is not repeating in there, so 0.583 recurring, where the 8 and 3 both repeat, so 0.583, 83, 83. Similar for 7/22, we get 0.3181818, so 0.318, where the 18 is recurring. 1/7 and 3/7. Sevenths are tricky because you have to go quite a way before you start having a repeating pattern. And it may have been that you had to go 0.142857 and then repeat 142 or the whole thing to make sure it does actually repeat. But you do get 6 digits repeating in a pattern for sevenths. Same for 3/7, 0.428571, 428571, and it continues in that pattern. Alright, I hope you found it useful. Thanks for watching. Bye for now.